need oxygen, and what do they actually do to the level of oxygen in the... They deplete it. That's right. They actually take too much oxygen out of the water. People go, well, yeah, that's good because they'll put oxygen in it, but the animals don't live long enough for that to happen. Okay? So that causes a limiting factor. That's why we don't like for people to do that. Okay? Granulated fertilizer is best put down when you know it's going to be a soft rain or you're going to water it in. But I love when people go, oh, we got a thunderstorm. And where does it mostly end up? In the gutter and down the drain. Okay. All right. So this is our first three classes of your animal, your vertebrates, okay, is fishes. Okay. So I'm just doing vertebrates with you. And then you have this guy. Who's he? Froggy. Well, who's he? Amphibians. Okay. Amphibians are great pollution indicators. Y'all know that? Man, insecticides and pesticides can kill, and herbicides can kill them off fast. So when I first moved to Lubbock, I would have to herd those toads, those little brown baby toads. You know, we get a big rain in spring. I would have to herd them. I would mow really slow, and I'd get them all over there. And then I'd have to wait, and I would have to get out, and I would have to shoo them to where I had mowed, and then I'd mow slow and make sure they were all over here. Now, I never have to hurt them, they're not even around. Don't have any.
All the insects.
That's
Babies
right.
are coming back at our place.
They're starting to come back.
Thousands of toads.
Good. That's a good
The
thing.
babies are coming back.
That is good. So that's one thing. And like in our rainforest, the tree frogs, they're a good pollution indicator. We have sections of some of the rainforest where those frogs are just disappearing. So amphibians have land and have water. Okay, so we know that those are good indicators. Okay, limiting factors for them is moisture. They can't get too far away from a water source. Like if those big toads get in your garage and you don't know they're in there, well, you find them later, they're mummified because they lose water. Okay, now reptiles are totally land dependent because they developed two things, a watertight skin, and they developed this really cool thing where I can put the pond inside an egg. Yeah, they developed that watertight egg. So they were the first ones to be totally independent of land, okay, is the reptiles. All right? Then we go to who? Our aves, that's right. Okay? Now they use that little pond. They still have their eggs, we all know. We know it's a good nutrition, great source. It's the perfect meal. An egg is a perfect meal. I don't care about all that cholesterol and stuff. It is a perfect meal. Okay? It's good brain food. It helps myelinate your brain. It's got good stuff in it. All right? But birds also came up with really cool ideas of how to do weight saving. All right? So like, the females only have one side, only half of a reproductive organ. Okay? Really, really spongy bones. They really came up with, and they're warm-blooded. They're the first warm-blooded set. And then, of course, then we have our mammals, which you guys are familiar with. But we got rid of the egg after we had the monotremes. You know who monotremes are, right? The platypus. Ever seen a platypus? Looks like part of a duck and part of a beaver put together.
Yeah.
And they have little eggs like this, but they hatch out early, and then they find this little area right here on the belly that secretes a very high protein kind of, it looks like milk. But y'all know that mammary glands are actually modified sweat glands. Yeah, it's sexy, isn't it? Okay. Yeah, those are some modified sex glands. Yeah. So some of, we know some girls, bless their hearts, they're modified so big that bless their hearts, their backs are, yeah. That's what they are. They're modified sweat glands. So, and then we get the pouched animals, right? The marsupials, same thing. The little nipples, they actually have a nipple, but the monotremes don't have a nipple. Okay, and then we have the placental. Okay, all of it was to get more and more independent. Now notice also, as we go up, we get more protective of our offspring. So you get more and more parental involvement in protecting the offspring, right?
Right.
Okay? So you get more learned behavior. So we get more selective about who we're going to breed with. Right? Okay, so remember I told you two things. Animals' behavior lives for two things: eating and reproductive, successful reproduction. Now, if I'm a female and I want to successfully reproduce, I want to pick a male that has the strongest traits, right? Now, birds are funny. Some species of birds will mate for life, like doves. Okay, I hate to hit a dove because, where the other half is, okay? So, mallards will mate for that season. And then they might trade partners, they may not, okay? But here's what's interesting. Some species of birds, they're funny. He'll build a beautiful nest and she'll shop around, right? And she finds that mate that builds a great nest and is a great provider. And while he's out getting food, she'll actually breed with a bigger, stronger male. Isn't that funny? Yeah. So he doesn't know any difference. They're chicks, okay? So she picks a good provider, but she breeds with a more, a bigger, stronger male. Yeah, isn't that funny? Yeah. I know, it's a whole, I can't remember the species. There's several groups of them that do that.
They're geese.
Huh? I think finches are one of them that does that.
The geese pick one
Yeah,
forever.
that's right, they do. The Canadians. Or Canada geese. They don't like to be called Canadian. They told me they don't like that. No, just kidding. No, really. Not really. Okay, so that's behavior. So when you look at behavior in natural selection, remember it's based on what? Either I'm getting food or I'm what? Successful reproduction. Not just picking a good mate, but also taking care of the offspring until what? Okay, so for instance, if I get a kangaroo and she's got a joey over here, do you know they'll practice? She'll make a sound and the joey will run and get into the pouch. And they practice. So if there's danger and she makes that sound, the joey runs and gets to the pouch. Then there's lazy mothers who don't practice. Maybe they're not even paying attention. What happens to the joey? Dinner. That's right, it becomes dinner. That's right, just like in humans. You know, we have some moms and dads that are very what? Protective, and they know, and sometimes overprotective. And then we have some that, yeah, whatever. Yeah, it's not good. Okay. All right. So, when we get down lower here and we go up, you also notice that fish and below and invertebrates, you get more what we call innate behavior, which means you're born with it, it's programmed. But as we start going up that chain, notice how we get more complex. But we also get less innate and more ability to what? Learn. And wild animals, they learn. They learn their environment. Okay? Does that make sense? But we always have to teach people, a wild animal is always a wild animal. And so if you trigger that innate behavior, it's going to respond how? As innate. Like when I had my iguana, if I approached him, I had to introduce that I was there. I'd click, I'd coo him, he'd know my voice, then I'd start petting him. I couldn't just reach up and start petting him because he'll think what? Someone's going to eat him and he's going to bite him. Yeah, because it's an innate thing. Does that make sense? That's why hybrid wolf dogs can be a good thing, but they can also be dangerous because they can have a quicker trigger to innate behavior. All right? So we have to understand, and I love Walt Disney World, I do. But unfortunately, they give too much anthropomorphism, okay? So we always have to teach children, yeah, that's sweet, but really lions don't sing. Okay? They really don't. And baby cub lions don't really hang out with their dads much because the dad will eat them. I hate to tell you that because they hang out with mom and they learn how to hunt and all that stuff with mom and play. So it's kind of cute, and I love all those movies, but at the same time, that's why you'll love a hare. There's a hare in my dirt. It's a worm story. It's an earthworm story. Oh, it's hilarious. But it kind of helps you get that mindset of being a biologist. So, All right, quickly, let's look at the back here and look at some of these test questions. And I do have something to pull up for you if I have time. I don't know if I'll get it or not. I've already covered all your competencies. Woohoo! Look at that. I know. You see the practice test questions back here? We won't do them all. Don't worry. I won't keep you after 4.
I'm a big day tomorrow.
I can see some of your brains, so I know. I can tell already. Yes, and I hope you come see me tomorrow. Super sessions. Super sessions. That's right.
You're gonna walk in and go super. You're gonna
That's right. I'll do it. I'll do it with you. Okay. Try not to look at the answer. Okay? Competency uno. Okay, you read it, not me. No peeking. No one's going to know if you got it wrong, but who? Just yourself. Okay? And if you'll see over here on page 10 on my outline, to you, besides good luck. Okay? Preparation, not procrastination. Okay? I honestly would work on this test every day. I would for 30 minutes, okay, or 45 minutes. I would work on this test every day. Okay? And I would know, I would go through those and I would click them off. Know it, got it, understand it, good. Don't know it? Go look at what we did in here. Google it. Okay? And I would get where I'm comfortable with it. All right? Energy pyramid. Yeah. Energy pyramids, even though I'm almost out of time, just remember, you got the producers on the bottom. Y'all remember that? And then you get an herbivore who eats it like a grasshopper. And then a bird eats the grasshopper, right? And then, let's say a bigger bird eats that bird. Okay, you see the food pyramid? Each time something is eaten, only 10% of the energy is passed up. It's called the 10% rule. That's why it's in a pyramid. Okay? Why? What happened to the other set of energy? It was used by the animal. Yeah. Okay. Does that make sense? That's why as omnivores and carnivores, we eat more. Okay? All right. So if you look at this real quick, all right, what are we looking at? Did you pick it right? Okay, you felt like you did? Explore how varied combinations of factors are likely to affect the population growth. He went in there and he tried to only pick what? One variable. There's no way you can do one variable when you're trying to do a species of insect. You got to look at what? Everything, okay? All right, so you can look at this test. Let's see here. Oh, look at competency 2, DNA. All right, I'm going to tell you a little history about DNA. You guys ready? You ever heard of Rosalind Franklin?
Yes.
There's one. Anybody else? There's 2. All right, anybody heard of Watson and Crick? Raise your hand if you've heard of Watson and Crick. Okay, what are they known for?
DNA.
All right, good. They did not discover DNA. Rosalind Franklin did. She just didn't know it. So let me tell you a little bit about Watson and Crick, okay? They're not bad guys by any means, okay? They were very intelligent, and one was working on hemoglobin, so they knew the structure. But it was a race for DNA. All kinds of people were doing research, and she was doing major research. And she actually is the one who discovered it was a helix. And she even presented it, and he sat there and he took the notes, and they went back and they made a model of how they thought the DNA looked. And then they invited everybody. Well, they did it wrong. And so she told them, well, that can't work because that can't work, and those hydrogen bonds can't go that way. Well, what she was actually not even realizing is she was giving them what? All the answers. She just was so in the forest, she couldn't see the trees, and when she left, Within a month, they fixed everything and they put it together and they got the credit for discovering DNA. But what they did is they took to work over here and the work over here and Rosalind's work and this work. She got the Nobel Peace Prize. Well, they really couldn't give it to her because she had already died. She died of cancer. But she's the one that did most of the work, but they got the credit. Because they stood outside the forest and said, oh, let's take and this piece goes together and this, but everybody else was so buried that they couldn't want. Because DNA actually is amazingly what? Simple, okay? That's a simple little thing. That's why it works so well. It's not, you think it's complex?
I don't know.
It's not. See, DNA. One side runs this way and the other side runs that way.
Just they started talking about 3' and 5' and
Oh.
don't know the mathematics.
Oh, because it's just the direction that it's copied. Yeah. Okay, so now read that. Okay, so a lot of experiments went to, but what did they do? They put it all together. Okay, all right, this next one. Now I'm going to show you a key here. Okay, and you might even put this note down here on this. Ready? If they give you a graph or they give you a picture, remember, you have to go by what's in it. The answer is there. Okay? Don't do anything subjective. Go exactly what they're showing you. All right, so if you look at this graph, what happens at 40 degrees? Man, what happened to the enzyme activity? It plummeted, didn't it? Okay, so just look at what it's telling you. Then pick your answer. Okay, y'all familiar with hamburger? Ever eat it raw? No, that's a good thing, especially now, right? What do you usually do to the hamburger? Okay, does it look the same as when it was raw? Okay, so what does heat do to protein? It changes its shape, it's called denaturing, right? Okay, if you denature an enzyme, what do you do to its active site? You change it, that's right, so therefore it can't what? Work. So at 40 degrees, what happened? It changed the shape, and boom, its activity fell. All right? Okay, so you can look through the rest of these. Okay, I don't think there's anything. Oh, yeah, go over here to competency 12. Look at 6. No cheating, man. Okay. There you go. What kind of cross is that? It's a dihybrid. Okay, so it's telling you the genes for green color and short fruit. Okay, so green is dominant and short is dominant over what? Striped and long. See how I did my key as I read it? Okay. 2 watermelon plants are heterozygous for both characteristics of red. So what do we got? They're telling you cross these 2. Okay. All right, what fraction of offspring from this cross would it be expected to have green and long? Okay, so we know we're looking for this one. Okay? Now you're thinking, oh God, we're going to sit here and do this. But didn't we already do this cross? Didn't we already do 2 hybrids? And what was your genotype on those 2 hybrids?
1, 2.
Okay, that's genotype. Okay, now what was your pheno? Because what's it asking you? What fraction of offspring would be green and long? We're not asking hybrid or anything else. We're asking phenotype. Okay, so which one? How many would this be? If you remember, it was what?
116.
9331, right? Okay, so what's your answer? That's right, 3/16. Now, if you weren't confident about that, you could easily flip this over and do what with it? Work it out. But every time you cross 2 hybrids and a dihybrid, you're going to get 121, 242, 121, and a genotype of 9331. All you have to do is work it out 2 or 3 times. You're like, oh my gosh, same thing. Yeah, same thing. Okay, ooh, there it is. Isn't that cute? Yeah. Okay. See how they worked it out? See, they were asking you to take this and work that out. And that's right. Nope. She's like, I'd rather have a margarita. That's right. Okay. Any questions? Let me show you something. If I go to this next one here. In contrast to reproduction in the division of plants, reproduction in an angiosperm. Okay, I don't know what an angiosperm is, right? Well, actually I do, but okay. What do? I get on my computer and I put in what? Okay, it's a flowering plant. Okay, so if I'm reading through some test questions, I don't know what something is, what do I immediately do? Google it, see what it is, then answer your question. Okay, don't just immediately jump to the answer, all right? Now I'm telling you, if you'll put in time, at least 5 out of 7 days, and you truly, truly work on it, you're going to be in pretty good shape, okay? But now hopefully you're not as afraid of the genetics, okay? You feel a little more confident, all right? Are y'all tired? No, not tired, I'm good, all right? Do you feel like it's worth your time?
Yes.
All right, y'all were great. All right, I didn't do all these. All the papers that are right there are all yours. Okay, this test competencies are yours. They came off your website. Okay, they're for your test. So practice it, do them, do your dihybrids, got your steps. And let's see, how many people do we have here? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right. And some of you have already taken, right? How many have already taken and passed?
Oh, fast.
No, and passed. Okay, just one. Okay, so I hope to see by next year at this time 20 out of 20. Okay? Practice that essay. Okay? Practice that essay. Don't be afraid of it. Attack it. Okay? Be proactive. And I have CDs up here if you want them now, if you want to try to